welcome to the first instructional video of the year. So this video is going to focus on the concept of the limit. What is the limit? Why is it important? And how is it going to become the foundation for all of the other topics that we're going to learn in this course? So it's the first because it's the most important. So just a little brief overview of how these videos are going to work. So this video is going to focus in on the concept of what is the limit. And in other videos, I'm going to then be talking about and doing actual specific examples, both from the text and from your problem set. So this will hopefully streamline your work. So instead of having to watch an hour-long video, if you need to just see some more examples worked out, you can just watch those specific videos, which are shorter in length. If you need some help with the concept, you can come and watch a video like this one, where I kind of get in depth with what exactly it is. Okay, so without further ado, we're going to go ahead and jump into what is a limit. What is a limit? So I'm going to go ahead and just put an expression here just to kind of get us started. So let's say I'm going to say limit x approaches 2, and I'm just going to put a function here, x. Well, actually, let's say x squared. Okay, so how do I read this? What is this telling me? So this is saying, and I'm going to put it here in words, the limit as x, and if I could spell, let's try it again, approaches 2 of x squared is dot dot dot. So the limit as x approaches 2 of x squared. So the key word, and this is the concept, a limit is what our function approaches. Okay? So the limit is what a function or expression, doesn't have to be a function per se, limit what a function or expression approaches as we approach a particular x. There you go. So you'll see the keyword that keeps popping up over and over and over again is approaches. We don't ever get to be the actual value. We don't get to be 2. We're going to get close to 2. And there's going to be several ways that we're going to see this idea. And I'm going to show you here the first way, which is shown in your book, is the numerical or tabular way. So I'm going to do here a tabular. So let's say we made a XY chart. So here's X, and our Y would be this X squared. So we're going to approach is 2. Okay? So we're approaching the value 2. Now I could approach 2 two different ways. I could be approaching 2 from the left side. So let's say I have a number line. So let's envision this number line. And here's the value of 2. So I could approach 2 coming from the left. So I'm going to plug numbers in to my function, which is x squared, where I'm getting closer to 2. Now I'm never going to plug in 2. I'm approaching 2. So let's say I start off with, okay, I'm going to plug in like a 1.8. So what would be the value? So I'll punch that into my calculator, and I'm cracking it open right now as we speak, and I'll do a 1.8, and I'll square that, and I get 3.24. Okay, so All right, I see for this one particular value I get this answer, but I don't know yet what I'm approaching. Maybe as I get closer to 2, the answer gets smaller. Maybe as I get closer to 2, the answer gets bigger. I don't know. So we're going to keep getting closer to 2. So let's say I do a 1.9. So now, again, I'm going to put that into my calculator, pop that in, and I get this time a 3.61. So I see the numbers increasing, but I don't really see a definitive value that it's approaching. So I'm just going to keep incrementally getting closer. So I'm going to do 1.99. So now I square that and I get 3.9601. So I see, okay, I went from a 3.2 to a 3.6 to a 3.96. Okay, so it's getting bigger, but notice it didn't take as big of a leap from here as it did in this second iteration. So if I keep getting closer, and that's the key word here, closer, I'm approaching. So that's the limit. I am approaching. You never see me ever going to plug in 2. I'm just getting closer to 2. And what I want to get from this is, well, what is the answer approaching? So if I go 1.999, I square that, I get a 3.9960, and now we're going to make some space here because we're really getting some more digits this time. 6001. So I'm seeing, okay, now I start to see with everything together, I start to see this pattern. I get closer to 2, and it looks like this answer is getting closer to 4. But let's verify. What if I keep getting even closer? And this is the what I would like to say, the calculus concept. And this is going to happen all throughout this entire course. Calculus is partially the study of the infinite. Okay? We're no longer going to look at discrete things like 1, 2. There's an entire universe between 1 and 2. An infinite, a continuous universe. So we can continuously keep getting closer and closer to 2. I could keep saying 1.9999999999999999999999999999999 forever. What would it be approaching? And I know, and I could punch that in my calculator. This could keep going into, like, now I would see if I do it here. So let's say 1.9999. I square that, and I see I get 3.9996001. So you see, I got now an extra 9. So if I keep tacking on 9s, this is just going to keep now saying 3.9999999999999. So what is it approaching? So as I come from this side, it seems that this x squared is approaching the value of 4. Well, what happens if you come from the other side? So again, here's this 2. So I'm going to put a question mark there because we're not going to plug it in. We never plug it in. So now on the other side, I would approach 2, but from bigger values. So let's say if I extended this table, so I'm going to get really, really close here. I'm already going to just have it set up. Kind of like we did on the other side. I'm going to do a 2.1, and let's even say 2.2. Okay, so if we start from this end, all right, so 2.2, and I square that, I get a 4.84. Then I got a 2.1. I got a 4.41. So you see, as I get towards 2, I'm coming from this end. I already see, okay, well, the number's decreasing. But again, just 2 numbers in, I don't really see, well, what is it approaching? Maybe it's approaching 4.1. Okay? I need to see that infinite, that continuous pattern. Do I see a trend? Okay? So now I go 2.01. Let's square that. Now I get 4.0401. Okay, so I see another drop, but not as much as it did before. Okay, so now we keep stepping more into it. So now I got 4.004001. Okay, so you see, okay, we're getting even closer, and it looks like, again, I'm getting that trend. It looks like it's approaching 4 as well. So when we evaluate a limit, okay, and I'm going to shove this down here. So when we evaluate a limit, we have to get to a consensus as we approach from both sides. So a limit exists, and I'm going to put here, quote unquote, exists. That's a key term, okay? Exists, meaning, and I'm going to put in green here, so when I say exists, meaning there's an answer that I would put at the end of this. So a limit exists if we agree to the same value on both sides. Or let me say coming from both sides. So we see here, no matter which side we come from, there's only two sides. Either I come from the low end or I come from the high end. So no matter which side I come from, we're getting to a consensus. We're coming to an agreement that, yeah, as you get closer to 2, no matter which way you're coming from, we're going to eventually meet up, boom, at this value of 4. So we would say the limit exists and the limit value is 4. Now, you might go and say, well, you did all that work. That's kind of dumb. If I just plugged in 2 from the beginning, 2 squared is 4. So why can't we just evaluate it like that? Well, there's a reason why, but we'll get into that later on in this section as we talk about limits, because the fact that 2 squared does equal 4 tells us about a property of this function that's going to become very important. It's going to be one of our key concepts in calculus. So for right now, we're going to just chalk it up to, well, it's a happy coincidence. It's not always going to be the case that a limit is going to be equal to the actual value if we were to plug in the number. If it does happen to be the same, that's going to infer a property about the function. Well, guys, hopefully you found the video informative. If you did, please hit the like button at the bottom. Also, you can send me comments through email. And a little bit longer than I would have liked, but again, this is the first video, so it takes a little bit of getting used to get the timing just right. And we're going to get more stuff in here, so up to production quality. So I feel that the more it's a little bit entertaining to you and not just kind of a dry lesson, that the more you'll be tuned in and hopefully let the material stick a little bit more in your heads. So I'll see you guys in the next video.